All right, here's a verbal explanation of slide 29 in your digital notebook. So slide 29, talks about the need, have, share method of drawing Lewis structures. So that is the method that I will use for this. However, if the trial and error method works, the drawings should be the same. So you can either listen to the explanation or just check your drawings. So for O2, if we do our need, have, share. So first we have to position our atoms. Since we only have 2 atoms, you are going to have oxygen side by side. And then we'll do our calculation. So the need is how many electrons all atoms need to be stable. So oxygen needs 8 electrons to be stable, like a noble gas. So each oxygen would need 8 electrons. So total, we would need 16 electrons. The have is how many electrons they actually have when you look at the periodic table. So oxygen is in group 6. So oxygen would have 6 valence electrons. Each oxygen has 6, so 6 times 2 is 12. When you subtract these, you get how many electrons are being shared. So remember, one bond represents 2 electrons. So if we divide this in half, this would show how many bonds the drawing would have. So this drawing will have 2 bonds. This is the only place that we can put a bond. There's only 2 atoms. So both bonds, or all 4 electrons, have to go between those 2 oxygen atoms. So we would add the 2 bonds in, and then once we get those 2 bonds in, then we have to add the extra electrons so that each oxygen would have or share a total of 8. So this oxygen would share 2, 4, so we would have to add 5, 6, 7, 8. All right, the next one, CF4. I'm going to change marker colors here. So first, we have to find the central atom. If carbon is in the atom, carbon will be in the middle because it wants to bond and share 4 more electrons. So carbon will be in the middle. And then these 4 fluorine are going to be positioned all around the carbon. So once you have that, then we'll do our need, have, share. I'm going to put that over here. So need, all atoms need 8 electrons to be stable. So we have 1, 2, 3, 4, 5 atoms that need 8 electrons to be stable. So total, we have 40 electrons, or we would need 40 electrons. For the have, that's when we look on the periodic table. So carbon has a total of 4 valence electrons. Each fluorine has a total of 7 valence electrons. And we have 4 fluorines. So 4 times 7 would be 28, plus 4 more is 32. So we have 32, we need 40. Once you subtract those, we find that we're going to share 8 electrons. Each bond, remember, represents 2 electrons. So if we divide this by 2, that gives us 4 bonds. We have 4 fluorine atoms that need to be bonded to the central atom. So one bond will go here, the second will go here, third one will go here, and a 4th one will go here. That's our 4 bonds, or our 8 shared electrons. Once you get all those shared bonds in, then you add the extra electrons so that each atom has or shares a total of 8. So fluorine over here would have 2, 3, 4, 5, 6, 7, 8. This fluorine has 2, 3, 4, 5, 6, 7, 8. This fluorine is sharing 2, 3, 4, 5, 6, 7, 8. And this fluorine has 2, 3, 4, 5, 6, 7, 8. Carbon is sharing 2, 4, 6, 8. So carbon is good, it's stable, it's happy. All right, my last one. Again, I'm going to switch markers. The last one is PCl3. I'm going to move this down a little bit so you can see this bottom drawing. So first you have to figure out your central atom. Central atom would be phosphorus because it is in group 5. So groups 4, 5, and 6 are generally your central atom, but also we have 3 chlorine atoms and only 1 phosphorus, so that's another indication. So we have 1 phosphorus and 3 chlorides, so we'll put those chlorides around the phosphorus central atom. And then we'll do our calculation. Need, have, share. So again, all atoms need 8 electrons to be stable. So we have 1, 2, 3, 4 atoms that need 8. So we would need a total of 32 electrons. Then we count up how many they actually have. So phosphorus has 5 valence electrons. Chlorine has 7, and there's 3 chlorine atoms. So 3 times 7 is 21, plus 5 more is 26. So we have 26. So when we subtract those, we find out that we will share 6 electrons. 6 electrons would represent 3 bonds. We have 3 chlorines that need to be bonded to the central atom. So there would be our 3 bonds. So none of them will be a double bond because we can only share 6 electrons, and these 3 bonds would represent 6 electrons. So now once we're done with our shared bonds, we are going to add in our extra valence electrons so that all atoms have or share 8. 1, 2, 3, 4, 5, 6, 7, 8. Oops. This chlorine is sharing 2 here. 3, 4, 5, 6, 7, 8. Chlorine over here is sharing 2, 3, 4, 5, 6, 7, 8. Phosphorus is sharing 2, 4, 6, 7, 8. So we got to add these 2 electrons on top of phosphorus. So these extra electrons are a little annoying to draw, right? But they are important because some of them, like this, will alter and determine the shape of the molecule, which in turn changes the properties. So hopefully this helps. This is the need, have, share method. Either method is fine. Just use what works for you.